Pydantic AI agents dispatch work to the model through tools, and how those tools reach the agent matters when the function needs to read or write RunContext. The artifact below demonstrates two registration patterns that produce equivalent agents, each running a dice game where the model calls a roll function and a name-fetching function. The code defines two agent instances, one passing plain functions to the tool's argument and the other wrapping them in explicit tool instances that declare whether the function takes RunContext. Then both agents are run synchronously with a player name supplied as a dependency.
Import random. From Pydantic AI import agent, RunContext, tool. Instructions. You're a dice game. You should roll the die and see if the number you get back matches the user's guess. If so, tell them they're a winner. Use the player's name in the response. Def roll dice SDR. Roll a 6-sided die and return the result. Return SDR random. Random 1 6. Def get player name text. RunContext SDR. Get the player's name. Return ctx.deps. Agent A equals agent. Google GLA. Gemini 3 Flash Preview. Deps type equals SDR. Tools equals roll dice, get player name, #1. Instructions equals instructions. Agent B equals agent. Google GLA. Gemini 3 Flash Preview. Deps type equals SDR. Tools equals #2. Tool roll dice, take ctx equals false. Tool get player name, take ctx equals true. Instructions equals instructions. Dice result. Dice result A equals agent A. Run sync me guess is 6. Deps equals Yashar. Dice result B equals agent B. Run sync me guess is 4. Deps equals Ann. Printis result A output. Tough luck, Yashar, you rolled a 4. Better luck next time. Printis result B output. Congratulations, Ann, you guessed correctly. You're a winner.
Two agents are set up with identical tools registered via the tools argument, but Agent A passes bare functions while Agent B wraps them in tool instances with explicit take ctx flags. When bare functions are passed, the agent inspects signatures to auto-detect whether RunContext is needed. So roll dice gets treated as plain and get player name gets context access. Agent B makes that distinction explicit through tool roll dice, take ctx equals false, and tool get player name, take ctx equals true, giving you fine-grained control over how each tool is invoked. The practical difference is that bare function registration is convenient for quick setups where signature inspection works. But tool wrappers let you reuse tool definitions, override auto-detected behavior, or customize tool metadata like name and description. Both agents run against the same model with the same instructions, and the output shows the LLM correctly using each tool to roll the die and fetch the player name from ctx.deps. Let's break it down.
Import random.
Imports the random module for generating pseudorandom numbers and making random selections.
Def roll dice SDR. Roll a 6-sided die and return the result. Return SDR random. Random 1 6.
Defines a function that generates a random integer between 1 and 6 using random. Randant converts it to a string and returns it as a die roll result.
Def get player name text. RunContext SDR. Get the player's name. Return ctx.deps.
Defines a function that accepts a RunContext parameter and returns the dependency object stored on that context. The docstring indicates its intended purpose is to retrieve the player's name.
Agent A equals agent. Google GLA. Gemini 3 Flash Preview.
Assigns Agent A to an agent instance configured with the model identifier Google GLA, Gemini 3 Flash Preview.
Agent B equals agent. Google GLA, Gemini 3 Flash Preview.
Creates an agent bound to the Gemini 3 Flash model through the Google GLA provider. The model string is the only visible parameter. Additional configuration likely follows on the next lines.
Dice result. Dice result A equals agent A. Run sync me guess is 6. Deps equals Yashar.
Creates an empty dictionary called dice result, then stores the synchronous run result of agent A, passing the prompt my guess is 6, and dependency value Yashar under the key A. Both registration patterns produce the same outcome because they're resolving the same question. Does this tool need RunContext or not? Bare function registration leans on signature inspection to answer that, which works fine when your signatures are clear. The tool wrapper makes the answer explicit, giving you reuse and override control. Underneath both setups, the model calls roll dice for the random result and get player name to pull the player name from ctx.deps, then weaves those into a response. The trade-off is convenience versus explicitness. Neither breaks, but the wrapper pattern buys you predictability when auto-detection isn't enough.
Agent calls roll dice through tool, while deps surfaces a name it never held.